Welcome to video 10.8c, the secant tangent power theorem. I'll work through example 2. Again, you've got several subparts in your page. I'll just select these 4 to represent the different types of problems. So just so you know, PA is a tangent segment and PB is a secant segment. So we'll be using OW equals OW. Alright, so again, use a pencil so you can erase the numbers for each of these 4 problems. So PA equals 8 and PB equals 32, and we want to find PC. I'll just call that X. Okay, so I'll start with OW equals OW. So I'll say X times 32, X times 32 equals 8 times 8. 8 is the outside and 8 is the whole. Alright, so basically I've got 32x equals 64. So x equals 64 over 32 equals 2. And make sure that you answer the question. X was PC, which is what I was looking for. So PC equals 2. Okay, that wasn't too bad. So erasing those numbers and doing subpart C. All right, so PC equals 3, CB equals 24, find PA. Again, I'll call PA X. Once I get X, I'm good to go. All right, so I'll start with OW equals OW. Again, it's a really easy memory device. Please don't forget it. All right, so I'll go X times X. Again, it's the outside and the whole at the same time. So X times X equals 3. Now be careful, the whole is 27. So sometimes students would just say 3 times 24. 3 times 27. So that's going to be x squared equals 81. So then I take the square root of each side, the plus or minus square root. So I'll square root this, plus or minus square root that. So x equals plus or minus 9. It doesn't make sense that I could have a negative length for a side. So I'll just say x equals 9. And then x was what I was trying to solve for, so I'll say PA equals 9. Okay, that wasn't too bad. 2 more to go. All right, so again, erasing the numbers. Not the letter, I think that was letter C there. All right, so now PA is 8. PC is equal to CB, so I could say your X and your X, find PC, which is really find X. Okay, once again, OW equals OW. So I'll say this whole thing here is 2x. So outside times whole, x times 2x equals outside times whole, 8 times 8. Okay, so I'll do the math. 2x squared equals 64. So x squared equals 32. Again, I'll do that plus or minus square rooting. So square root, square root. So x equals plus or minus the square root of 32. It doesn't make sense for x to be negative in this case, so I'll just say x equals the square root of 32. And then I'll simplify that. One way that I do it is I say, oh, it's the square root of 16, the square root of 2. 16 happens to be a perfect square, the square root of that is 4. So x equals 4 radical 2. X was what I was trying to find, so PC equals 4 radical 2. Okay, 1 left to go. Again, I'll erase those numbers. trying not to erase the points. And I'll go back to red. All right, PA is 2. BC is 3. Find PB. I can just call that X, if you will. Or if I wanted to, I could call this X, and I could call this X plus 3, just if you want to go subtraction or not. So I think I'll keep it positive. So I'll call that X, and that whole thing X plus 3. Okay, just be careful, you want to find PB. All right, so once again, OW equals OW. So X times X plus 3, X times X plus 3 equals 2 times 2. Again, that 2 is on the outside, and it's also the whole. Okay, distributing. X squared plus 3x equals 4. Standard form. X squared plus 3x minus 4 equals 0. So I want to get a product of numbers to be -4. So it's going to have to be a mixture of signs. And I want the sum to be positive 3. So I'm thinking of a positive 4 and a -1. So I'm thinking of x plus 4 times x minus 1 equals 0. Again, don't be afraid to do your OI check. That's 4x minus 1x, sum's 3x. Then chunk it up. And I'm going to get x sub 1 equals -4, and x sub 2 equals 1. It's not that x can't be negative, it's that a side length can't be negative. So since I have just x there, there's no way x can be -4. Let's make sure that 1 makes sense. 1 makes sense there. 1 makes sense there. So let's answer the question. Find PB. So PB is x plus 3. So PB equals x plus 3 equals 1 plus 3 equals 4. Whew. So there you have it. A few examples on the secant tangent power theorem.